All right, in this problem, we are being asked to find the radius of this circle that we're looking at. We have a triangle given to us, and in diagram point B, so point B right here is a point of tangency. So that's the important piece of information that helps us to solve a problem like this, because what we're given here is not enough information other than the fact that we now know that B is a point of tangency, which means we got a 90-degree angle there. And if we have a 90-degree angle there, that means we're dealing with a right triangle. And one of our most beneficial tools with right triangles is the Pythagorean theorem. So we could use the Pythagorean theorem here. The problem is we got 50 feet from point A to the edge of the circle, and then R is representing our radius. So this side isn't given as just one singular value. And we do have a singular value here of 80 feet for that leg. And then the radius here would be our other leg to the right triangle. So how would I go about this? I would just set it up in the Pythagorean theorem and use that information. I'll show you how to take something like that and plug it in. And let's get to it. So we've got a leg squared times a leg squared equals hypotenuse. That would be our hypotenuse of the right triangle, hypotenuse squared. How do we know it's a right triangle? Because they tell us point B is a point of tangency, which means that this angle would have to be a 90-degree angle there. So here we go. Let's say 80 squared plus R squared is equal to 50 plus R, or R plus 50 squared. I'm going to write it as R plus 50 squared. Okay, so we got to take this value here, square it. We got R, which is a variable representing an unknown. That's what we're trying to find the radius R of circle C. So we're trying to find what this value is to make this true. Okay, so 80 squared, 8 squared is 64, so 80 squared is going to be 6,400 plus, we still have R squared here, equal to, so R plus 50 squared. Don't make the mistake of just distributing the exponent to the R into the 50. You got to think of this as a binomial times itself. R plus 50 squared really just means R plus 50 times R plus 50. A lot of times kids would say R squared and they'll multiply 50 times 50 and get that value. So what we want to do here is distribute R times R gives me R squared. R times 50 is going to give me a 50R. We're going to get another 50R by multiplying 50 times R. And at the very end, 5 times 5 is 25, so we're going to get 2,500 here at the end. Okay, so now that you see what this becomes, 50R plus 50R is just 100R. So I can write this out as 3 terms. This binomial squared turns into R squared plus 100R plus 2,500 plus 2,500. Okay, now we've got an equation. Ooh, I see R squared and R squared. That's good news. That is good news because they're going to cancel each other out on both sides. So we got variables on both sides. Solve it like any other equation you've ever done in algebra, right? Minus R squared, gone. Minus R squared, gone. Now we've got 6,400 is equal to 100R plus 2,500. Okay, so now it's a 2-step equation from this point. We're just going to take away 2,500, inverse operation. This says plus 2,500. We're taking 2,500 away. It's going to go away on the right side. You take it away over here. That's going to leave me with 3,900 is equal to 100R. Divide by 100, this is multiplication, 100 times R. So we're going to do the opposite of multiplying. We're going to divide by 100. Divided by 100 is simple. So we know we're left with 39 is equal to R. Go back up here and ask yourself if that makes sense. Could this distance from C, the center of the circle, to B be 39 feet? If this is 80 feet, and this would be 50 plus 39, well, 50 plus 39, what's that going to give you? That's greater than 80, right? You need a hypotenuse that's larger than 80. So you've got 89 up here, 80 here, 39 feet there. Ask yourself if it makes sense. I'd say it sounds good. And that's how you tackle a problem like this. Okay, so you're realizing that because they tell you point B is a point of tangency, that gives you this information. Once you know that it's a 90-degree angle there, you can use the Pythagorean theorem just like you would any other right triangle to solve this problem for the distance of the radius. Hopefully this makes sense. Hopefully if you get a problem like this, you can stop, think about what route do I need to take to get there, and study hard and good luck on your upcoming test.